All right, so another thing that you can do as you're finishing a function out is you can actually return none. Sometimes it's useful, sometimes it's not. It's basically a null value. So on that ASCII chart that we looked at in module 1, the 0 value is actually called a null or a none. So if you return none in Python, essentially you're going to just return that null value. All right, so again, we also have we talked about the random module, right? So we also have another module called the math module. Okay, it's part of the standard library. It works just like the random, but it has a bunch of other really cool functions inside of it. So in order to gain access to it, you should already know how to do this. I go import math. Now I can name that as MT or whatever. I'm just going to call it math for now. That way it's a lot easier. And I'm also going to call random RD. Okay, so now that I have math imported, I can actually have access via dot notation to some really cool functions. So I can get the arc cosine, arc sine, arc tangent. I can get the smallest integer that's greater than or equal to x. I can get cosine. I can convert radians to degrees. I can get e to the x. I can get the largest integer that's less than or equal to, so ceiling and floor. I can get the hypotenuse of x and y. I can get log 10, I can get radians, I can get the sine of a certain thing. So we have a boatload of things. So we could do, why don't we do sine, cosine, tangent, just so you can see how this works. So let's just make a little function since we're in the function chapter. So def, we'll call this get cosine. And we're going to send in an angle. All right, so we're going to call it COS, and then we're going to use math.cosine. And we're going to give that to s, and then we're going to return cosine back to the function call. Okay, so we could do the same thing here with sine, right? Def get sine of x, and then I can do sine equals math.sine, and then I can put x in there, and then I can return that x, or sorry, return that sine. Okay, so now I've got a get sine or a get cosine and a get sine. Let's also make a get tangent. Def get tan x, and then we're just going to get a tangent, math.tangent, and then we're going to return that tan. All right, so I have these three functions that are relying on the math module, and now I can actually do stuff with that. So let's say we want to get some degree from a user. All right, so we're going to call it deg, and we're going to make it into an integer. Obviously, we're going to use the input function. And actually, let's go ahead and get that degrees from somebody. So we're just going to put pass here, and we're going to actually do def get degrees. Okay, so this is from a user. Okay, so I'm going to go deg equals, which stands just short for degrees. I'm going to convert it to an int. I'm going to take input, and I'm going to say, please enter the angle in degrees. All right, and then I'm going to return degrees. Okay, so now I've done that, so I can go ahead and grab the degrees. So deg equals get degrees. Boom. And then I can actually just get my sine and cosine in my tangent. So I can get cosine equals get cosine deg. And then I can get sine equals get sine deg. And then I can get tangent equals get tangent with deg. Okay. So now I can just go ahead and print those all out and make sure that everything's working. Cosine, sine, and tangent. Oops. There we go. Okay, so again, we made a bunch of functions here, very, very simple. Def, the name of the function, whether we have any parameters coming in, the body that we have and what we're doing, and then returning the value that we have. Okay, so this one functions as getting degrees. Okay, and it's useful sometimes to go ahead and use a hashtag. It says, you know, gets angle from user. Right, so just a little description that tells us what's going on here. So this one gets the cosine, this one gets the sine, and this one gets the tangent. Okay, so let's go ahead and run this and see what we get. So please enter an angle in degrees, 30 degrees, and there we go. We have 30 degrees, and then we have our different sine, cosine, and tangent. Okay, so that math module is really, really, really cool. I use it all the time. because it can actually give you a lot of really, really useful math information there. So cool thing about math is you can actually, it has pi predefined. So if you don't want to write in pi and e, you can actually just use those. So math.pi or math.e, right? So I can actually go in here and I can print math.pi, right? And it'll actually just print it out for me. Now it defaults to this value, but it actually has more decimal points than that if you want to make it do that. Okay, so it's really, really, really cool that you can actually just use math.pi times the radius squared. Okay, very, very, very useful. Sometimes we like to store functions modules. For now, we're actually going to skip over this because I'm not too terribly worried about that at this point. Maybe later on we'll actually create some of those. So again, menu-driven programs, we're not really going to talk about that much. It's pretty self-explanatory. So conditionally executing the main function. Okay, this is something that I've already showed you how to do, and this is something I want to see you do all the time. So it's important. It's possible to create a module that can be run as a standalone program or imported. Okay, so obviously we're seeing like this random and this math module as imported modules. Well, maybe we want to be able to make ours to where we can get this imported into some other Python file, so that they have access to get degrees and access to get cosine and access to get sine. But if I import that into another file, it sure would be nice if it doesn't just run the main method, right? Because I'm not running it with an intention of running the main method. I'm running it so that I can have access to the functions, okay? So that's conditional execution is what it's called. So if it is run on its own as a standalone program, it'll run the main method. Or if it's imported into another program, it won't run the main method. Okay, so here's sort of a scenario. Suppose program A defines several functions that you want to use in program B. So let's say we got get cosine, get sine, get tangent, and we want to use those in some other Python script. I can import program A into program B, and then I can just use those functions. So, you know, this would be chapter 5, import chapter 5, and then I can go chapter 5 dot get degrees using dot notation. Okay. However, you don't want it to execute its main function when you import it, and that's exactly what it would do if you just had main right here, like on the first level, right, on not tabbed in. If you just had it here, it would execute main. Okay. You don't want that to happen, right? You only want it to execute main when it's a standalone. So we have this if name equals main. And this is sort of explaining it, right? So when a source code file is loaded into Python, a special variable called the name is created, okay? So here is the variable that we're referencing, name, okay? The source code file has been, if the source code is imported as the module, the name variable will be set to the name of the module. Okay, so at this point, when random is imported, the name variable is set to random. When this one is imported, the name variable is set to math. Okay? Now, on the other hand, if the source code is being executed as the main program, the name variable is set to main. Okay? So when I run chapter 5 by itself, name is set to main. Okay? So if the global variable name is set to main, then I want to execute the main method. Otherwise, don't do anything. That's essentially what that's doing. That's called conditional execution of the main function. Okay, and we want to always do this. From here on out, all of your submissions have if name equals main with a main statement. Every single one of them, otherwise you will lose points. Okay, so I want to make sure that you do that. Do not miss that. You must conditionally execute the function from here on out. Okay, all right, and that marks the end of this module, or the end of this chapter. I know it's very, very long. The GitHub section of this is pretty short, should be pretty easy. So I think you should have an easier time finishing out this module now because the GitHub is a lot lighter. Okay, so I would encourage you, go into PyCharm, mess around, try to write some of these functions out and get good at writing these functions and understand how to write these functions because the homework is coming up here pretty soon, midterm's coming up here pretty soon, and I need you to make sure that you understand how to do these definitions, how to do these calls, what the appropriate sort of conventions are for this. Okay? All right, if you have any questions, you have any concerns or anything, just go ahead and email me, and I am right there for you to help you out.